In progress.
Good morning, this is your Stats Sensei, Mr. Spensei, and we're going to talk about observational studies and randomness and convenience samples and judgment. So let's get started. Well, as we've seen in our previous videos, it's really important to collect samples that are representative of the population. In other words, they need to be non-biased. So the question is, how do we go about doing that? And we have multiple methods, but one primary method, and probably the most common, or actually is the most common, is the observational study. And surveys are a type of observational study that are very, very common. And then basically they're asking people what they're doing, what they're already doing. How much food do you eat? What type of food do you eat? Who are you going to vote for? Also, historical records are and even medical records are types of observational studies, with surveys probably being the most common. Okay, and surveys has a long list of possibilities. Most data is collected through observational studies. Some are collected through experiments, but most are collected through observational studies like surveys. Observational studies do not assign treatments. That's critical. An experiment does, but observational studies do not assign treatments. Because treatments are not assigned, causation cannot be proved. And you need to know that. For observational studies, we can show correlations and relations, but we cannot say causation. Only experiments should be used to establish cause and effect relationships. And most data is collected by observational study and not by controlled experiments. All right. That said, observational studies can be statistically significant. All right. And as I said, they can demonstrate a relationship between or an association or correlation. So they're very powerful, but they're not as powerful as experiments because only experiments can show causation. Common types of observational studies is a survey, of which there are several. The census, which we've already talked about, where you survey everyone in the population. The convenience sample, we try to steer clear of those because they tend to overrepresent and underrepresent part of the population. Convenience samples are almost always biased and almost always underrepresent. The simple random sample, which is the gold standard of samples, and we'll talk about that in our next video, along with the systematic, which is another type of sample, the cluster sample, and the stratified sample. In this video, we're going to talk about the convenience sample, okay? And that's the only one, or a convenience slash judgment type sample. The census, as we discussed earlier, involves collecting data from each unit of the population. So basically, we're surveying each unit of the population. Unfortunately, as we mentioned earlier, it's impractical, if not impossible, to perform. So we rarely are able to do that. On the positive side, if we are able to accurately conduct a census, we have the population parameter. And in which case, we really don't need this class because inference procedures will not be necessary. We'll do inference procedures in the third and fourth quarter, but they're not necessary if you can conduct an actual census. The convenience sample is a sampling technique which selects subjects because of their convenient accessibility. They're convenient, all right? They're easy to get to. Convenience samples are rarely representative of the population, and not every subject in the population has an equal chance of being selected. As soon as you say that not every subject has an equal chance, it's biased. As a consequence, convenience samples are most often of no value. However, they are easy to perform if you're interested in collecting worthless data. In other words, we should avoid convenience samples. All right. Oh, one thing to note, randomness was not employed in the convenience sample or in the census. In the census, we surveyed everyone, so there's no randomness. In the convenience sample, we surveyed those around us, and that wasn't random. So the purpose of randomness, recall that we want our samples to represent the population, and that means we want our sample to look like the rear view mirror of the car, a small version of what you'd see if you looked out the back window. All right? That means we want every combination of traits to be proportionally represented in our sample. Unfortunately, if we break it down, we're all unique individuals. Thus, if we were to represent every combination of traits, we need to perform a census and sample everyone. As we discussed previously, it's impractical if not possible. So how do we address this problem that we can't survey everyone? The answer is the introduction of chance or randomness. By introducing chance or randomness, have found that statisticians have found that randomness equalizes the variation that we can't account for. So, if you don't believe me, let's try the exercises on the next pages and see what happens. First, we're going to not employ randomness. All right. So let's begin with your best guess is the mean average of the number of squares in each figure. So I just kind of looked around and I said, you know what? I think it's 12 because I have some bigger than 12, some smaller than 12, but I think it's 12. Turns out the actual value is substantially less. And I'm not sitting with it right now in front of me, but I'm pretty sure that the actual value, the average size is 7.9. All right. So then the next thing is like, well, just guessing one is probably too good. So why don't you randomly select 5, not randomly, but why don't I choose 5 that in my judgment, I believe would be the most representative? Well, I chose sample number 12, and sample number 12 had 9. I also chose number 24, and it had 1, 33, and it had 20, 43, and it had 12, and 52, and it had 16. Well, I added those up and it ended up being 58. 58 divided by 5 was 11.6, which is interesting because that's pretty close to the original 12 that I estimated. All right. And there's kind of a reason for that. So I ended up with an average of 11.6 when I chose 5 without using randomness. I ended up 12 just by my best eyeball estimate. And what that generally represents is I'm pretty normal. We tend to notice the big and ignore the small. So this was their actual value right here is the mean is 7.9 and or close to 8, and 12 and 11.6 kind of a long ways away from it. And it's because my eyes went to the big squares as opposed to noticing how many of them are actually small. So I guess I'm biased in that regard. All right. So in the next video, we're going to we are going to actually use randomness, and we'll conduct a simple random sample and a stratified random sample. All right. Hope to see you on the next one. Thank you for watching.